Hey guys, it's Miss Diamond. We're going to go over some statistics today. And it's going to be a couple of a mishmash of things. You guys did a lot of this stuff back in middle school, but I wanted to refresh and fine tune some of your skills. We're doing statistics this week and next week. Next week is going to be things like standard deviation and empirical rule. This week is a little bit more of a review. So the first thing I wanted to go over with you is the other video I was having you watch. It goes into qualitative versus quantitative. These are different kinds of categories versus numbers. So if I gave you a bunch of numbers, those are the types of graphs you're going to be using, as opposed to if I gave you categories, you'd be using those kind of charts or graphs. So that's in your other video, but there are some quiz questions on that, so please make sure to watch that video. Two words I want to focus on are discrete and continuous. We did this back in linear functions back towards the beginning of the year. Discrete is dots and continuous is line or curve. So when I taught you back then, I actually went through that discrete were dots, D and D, and continuous are lines and curves. So hold on one second. My thing just got lost. There you go. So anyway, discrete, you're going to have your dots or specific points, and then continuous or lines or curves. And that might help you remember which one's which. We did this. This is a lot of the functions that we did with linear, with quadratic. They're all continuous. A lot of the things we graph in statistics are discrete. So I'm going to look at a dot plot. A dot plot is a line with a series of dots, or sometimes they're represented by little X's, like little tick mark X's going up. So the first thing I'm going to ask you is how many people participated in this survey? And some people have the mistake of thinking that it's 4 because there's 4 numbers, or 5 because they count the 0, but it's actually how many dots there are. So we're just going to count 1, 2 dots, 3, 4, 5, 6, 7, 8, 9, 10. So there's 5 more. So there's 5 here, and then 3, and then 2. So if you add them all up, you have 2, 3, 4, 5. So 2 plus 3 is 5, 10, and then 15. So how many people participate in this survey? 15, because of 15 dots. What is the mean? Well, this some people actually get confused by. The mean is adding up all of these numbers: 0, 0, 1, 1, 1, and so on. You can add up all the numbers and divide by how many there are. However, there's actually a shorter thing. And if you notice, there's 2 here and 2 here, 3 here and 3 here. It actually is a symmetrical curve. So the mean is what's in the middle. It's actually that the mean and the median are the same in this situation, because if you knock out these 2 and these 2, these 3 and these 3, you're going to find the median is this one. And if you add up all of these numbers and divide by the 15, you're going to find that the mean, or the average, is going to also be in the middle. So in this case, the mean is going to be 5, and the median is also going to be 5. We're going to also go over bar graphs. Bar graphs are something you guys have done in the past with counting by bar graphs. So you can see, for example, that Central America is at 120, or maybe 121 if you want to be specific. And South America is probably at 20 or 21. What I wanted to point out in a bar graph that you might not have learned before is that sometimes people try to skew these and make them look greater than they are. So this graph in particular does not start at a 0. It starts at a 20. It is a broken graph. So if I was going to have something that was that was 10, 20, and then over here I was going to have 2, 4, 6, 8, 10, and there was a piece of data. Do you notice how if I wanted it to look like a lot, I could go by 2s, and if I wanted it to look like a little, I could go by 10s. So depending on how you do things, you can actually make the data look either really good for what you want or really bad for what you want. And that's actually something I wanted to mention, because with everything going on with the virus right now, people are making the data sometimes look less scary or more scary. So one of the tricks that they do is they don't start this piece at 0. You do have a quiz question on this, and I would pay close attention to where it starts. It might make the data seem a lot different than it actually is. These are box and whisker plots, also known as box plots. If you're one of my students, you're going to know my, I don't have a love of box plots, but we've gone over it, but I am going to review over it again with you guys just to make sure you remember. There are 5 really important pieces of data. The first 2 are what I consider the easiest. There's a minimum and a maximum. That's the lowest number and the highest number. So if you had something like 2 at the bottom and 25 at the top of a data set, then this would be your minimum and this would be your maximum. So hopefully you have no questions on that. The next important one is right in the middle, which is the median. So let's say right here you have a number in the middle of 15. And if you looked in the middle, I'm just going to fill in the other data points. So give me a moment. Okay, so if I look at this is my minimum. And if I look at this is my maximum. And if we look right here in the middle, that is my median. That is represented by this line right here. Then you have the lower quartile and the upper quartile. Now that I've identified my median, minimum, and maximum, what I'm basically going to do is I'm basically going to cross this out and cut this in half. And I'm going to find the average of these 4 and the average of these, well, I'm going to look at these 4 as a data set, okay? The middle of this, what is the median of this? Hopefully you guys can see that that's 5.5. That number right there is my lower quartile. So it's basically the median of the bottom and the median of the top. So 5.5 is my lower quartile. And up here, what's in the middle of the 18 and 22? 20. So that is my upper quartile. We are not going to ask you to construct one of these, but we are going to ask you to represent, to have to know, not represent, sorry. We're going to have to ask you to know what is going on, where you might need to identify that the median is that middle line, or you might need to identify that the maximum is that edge line. So if I asked you, what is the median of this, hopefully you can give me the answer. Okay, the next thing we've gone over, I know I went over it in Unit 4, linear functions, but I did want to put a spotlight on it again since it applies to statistics. There are positive correlations, negative correlations, and no correlations. Basically, as one thing goes up or increases, does the other variable go up or increase? If it is trending to go up, such as this one, such as this, wait, let me get my drawing thing. Such as this one, it is positive correlation. You guys can see I'm still learning how to use this. If it is trending down, it is a negative correlation. So basically a thing that can kind of have a positive slope is a positive correlation. And if you kind of have a negative slope, you have a negative correlation. Finally, if you have dots kind of all over the place, like there really is no relationship between them, then that is a no correlation. Let me recenter us. Okay. The other thing that we've gone over in the past is we've gone over a correlation coefficient. A correlation coefficient has to be somewhere between -1 and +1. If you have a perfect negative correlation, such as this one, see how it's absolutely perfectly lined up in a line, it would be something like -1. However, if the dots are kind of all spread out a little bit, then it would get closer to the 0. So it's going to be somewhere between -1 and 0 if it's negative, As the dots get more spread out, the more it gets close to zero. The same way it goes with positive correlation. If you have the dots more spread out, they're going to be more like a positive 0.5. And if the dots are perfectly straight, like in a straight line, then it would be positive 1. Correlation coefficient will never be less than -1, and it will never be more than positive 1. On this Edpuzzle, I'm going to be asking you a question about this, so I'm just putting it up there for a moment. These are also things that you've learned about in the past, mean, median, mode, and range. I just wanted to remind you of what those are. If you do not know what these are, you might want to do a couple minutes of research. Your quiz will have you figuring out how to do one of those, at least 1 or 2. So please know what the mean, median, mode, and range are. Another thing that we talk about is, when do we use the mean, the median, or the mode? When are they like the correct pieces of data? So if you have something that everything is perfectly symmetrical, I'm going to go back to this example real fast. This is what I meant by it's symmetrical. You have 2 that are at the bottom, 2 that are at the top. See how everything's kind of right in the middle? That's an example of symmetrical data. When you have something that's a symmetrical data, then it does not matter if it's mean, median, or mode. Usually the mean or median is fine. If it has categorical data, then you want the mode. Categorical goes into categories, which means you don't really have numbers. A mean really isn't going to work when there's no numbers. A skewed data and outliers we're going to get to in just a moment of what those words mean, and then that will be the wrap up of today's lesson. The mean, median, and mode, this is just a visual thing of what skewed is. These are actually models that we're going to go into exactly what they are next week. But if you notice, this curve in the green is nice and perfectly centered. So it goes up and down around the same area. And so mean, median, and mode all could work because it's not leaning to the side. Skewed kind of means leading. If it is negatively skewed, it means that there's less negative and there's more positive. So notice as we get to the positive world, the hump is bigger. So it's kind of gaining steam. You learned this with exponential, and then it's going to reach the peak and go down. If you have something positively skewed, it's really, really strong at the beginning, and then it's going to look more like a slide as you move towards the positive world. When they talk about flattening the curve with everything going on with the coronavirus, these are the kinds of curves they're going to be flattening. This is what we're going to get into a little bit more next week, so you actually know that everything they're talking about right now is very applicable to the real world. Last thing, just a reminder of what an outlier is. An outlier is something that kind of doesn't belong. So I like using the example of when you find heights of adult males and then you get to the basketball players, they are an outlier. They are not traditionally the same height as everybody else that kind of go. And those outliers is what skews data. So if you have something really out of the way and you find the mean, if you add that in, it's going to end up being making your data a little skewed. I hope that that was helpful. Go ahead and take your quiz whenever you're ready. If you need to watch this again, this goes through everything you're going to need on your quiz. And I hope you guys are having a great, safe day.